In this example, we're going to demonstrate several of the SPL data structures. The first structure we want to look at is the SPL heap data structure. So let's take a look at the definition of that structure in the standard PHP library. You'll notice on line 2 that the SPL heap implements two interfaces, the iterator interface and the countable interface. This tells us immediately that the SPL heap is iterable. It can be used in a for each loop and will know how to traverse the contents of the tree. Also, the countable interface tells us that the SPL heap has a count function that will return the number of elements within the heap's tree structure. The new keyword to pay attention to on line 2 is the abstract keyword. Abstract means that the SPL heap cannot be created directly, that it must be inherited from to create an SPL heap. And as we scan the functions defined for the SPL heap, we see on line 7 that the compare function is declared as abstract, meaning that we must provide an implementation for this function in the class that inherits from SPL heap. This requirement makes sense when we think that the SPL heap is based on an organized tree structure, because the organization of the tree is based on the values of the objects stored within the tree. Therefore, any class that inherits from the SPL heap must define a way to compare the objects that are being stored in the heap, because it is the comparison of the values of those objects that determine their position within the heap's tree. So let's see how we've implemented this. On line 6, we've declared our movie catalog class as a child of the SPL heap class using the keyword extends. Extends tells the PHP preprocessor that this class, movie catalog, is inheriting from SPL heap, because SPL heap is an abstract class, and that its abstract method compare requires that we implement that function. We do so on line 19, where we've declared the function compare as taking two movie object types as parameters. We choose to organize the movie objects within the SPL heap tree based on the title of the movie. Therefore, on line 21, we're comparing those title values of the movie objects. If the movie titles are equal and identical of type, that's the three equal signs on line 21, then we return 0. If the movie title of the first argument is less than the movie title of the second argument, then we return a -1. Otherwise, we return 1. These values, 0, -1, and 1, that are returned based on the value of the title of the movie object are what is used by the SPL heap object to organize its tree. Then on line 35, we declare a function insert movie that takes a single movie object as a parameter. Notice, however, that we are no longer storing the movie object within our own movie catalog code. We are now storing the movie object in the parent class, in the SPL heap. Therefore, we call the parent class's insert method, the heap insert method, and pass that object of movie type to the insert method. On line 39, we provide a function getAllMovies that's going to return the contents of the heap. On line 41, we call the heap's top function. Notice the call, parent : directs the call to the top function to the parent class. In this case, the parent class is the SPL heap. Then on line 42, we control a loop by calling the parent class's valid function, so that as long as there is a valid value in the SPL heap, this loop will continue to execute. Within the loop on line 44, we call the parent class's current function. This is going to return the current element within the SPL heap. That current element is a movie type object, and a movie type object has a function called display that will print the contents of the movie object. And then on line 45, we instruct the heap to move to the next element by calling the parent class's next method. And just as a reminder, we have not changed the movie class from the last example. So let's see how we execute this. First thing we do on line 9 is include the datastructures.php file that contains our movie catalog heap type object. Then on line 11, we create a new movie catalog. Again, remember, now we're creating a movie catalog object that inherits from the SPL heap. Therefore, with the call to new, when we create the movie catalog, we are also creating a heap object as part of the movie catalog object. On line 13, we create a new movie. On line 15, we insert that movie. So we're still using the same interface that we had previously used for inserting movies into our movie catalog. However, the implementation of that interface has dramatically changed in that now we are calling the parent class's insert method instead of storing the movie object in the movie catalog object's internal native array. And then on line 19, 21, and 23, we repeat the inserts. Then on line 25, we call the for-each method to loop through the movie objects contained within the movie catalog. And because the SPL heap implements the iterator interface, and our movie catalog class inherits from the SPL heap, our movie catalog knows how to iterate itself in a for-each loop. Within that loop, we simply call the display function for the movie objects to print their respective values. So let's see how the heap runs. I will reload this page, and the first thing we see again is our debug output from the movie catalog class constructor. Then we see the listing of the 4 movies that were contained within the movie catalog heap type object. One of the keys to this example is that we have dramatically changed the internal implementation of the functionality of the movie catalog class, yet to our user, the interface has not changed. This is an important point to keep in mind when we publish a class and that class has a defined interface, a defined set of public functions. We should think long and hard before ever changing that interface. Changing the way those functions do their work does not impact the user so long as we don't change what is required from the user to perform that functionality. As in this case, nothing that changed within the movie catalog class impacted the user at all. This is exactly the same insert code that we used in the previous example when the movie catalog was using a native array for storage. Now let's look at the stack. The SPL stack is a LIFO structure, a last in, first out structure. On line 35, we assign to the movie stack variable a new object of type SPL stack. The conventional interface for a stack is push and pop. Push inserts values onto the stack, and pop removes those values from the stack. So on line 37 through line 40, we are pushing or inserting values onto the stack. Then on line 44, we're doing a variable dump on the movie stack. So we're saying on line 48, while the stack is not empty. Notice the bang, not empty. Then pop a value off of the stack. Well, the value that's going to be popped off the stack is a movie type object. So we call the display function on that object to print the values contained within. So let's see how this runs. Again, I'll just reload the page. And for the SPL stack, here's our stack dump from the printr function, then the loop output from the call to each object's display function. Notice the order of the output. Our order of input was Alien, Blade Runner, 2001, and The Day the Earth Stood Still. So the last movie object that was inserted was the first movie object that was taken off of the stack or popped off of the stack. So that the order of the objects coming off of the stack is the reverse of the order of the objects as they went on the stack. Again, a LIFO structure. So let's look at the SPL doubly linked list. On line 58, we create a new object of type SPL doubly linked list, and we assign that to a variable movie list. One of the advantages of using the SPL is the consistent interface of the data structures. Notice on lines 60 through 63, this is a doubly linked list type object, yet we're using a very familiar interface, push. Push this object into the list. On line 60 through 63, we insert using the push function for movie objects. On line 66, we're going to set the iterator mode for the doubly linked list. This is a nice feature of the doubly linked list, that we can tell it how to iterate over its contents. In this case, on line 66, we're telling the doubly linked list to output its contents in FIFO order, first in, first out order. Then we loop on line 67 with a for loop, retrieving the values in the movie list. We control the for loop by first rewinding or going to the front of the list, the top of the list. We control the loop by asking the list if the current entry is valid, and so long as that current entry is valid, we're going to call the display function of that current entry. A current object in the list will be a movie type object that has a display function, so we simply call that on line 68. Then on line 73, we instruct the doubly linked list object to output the values in LIFO order, last in, first out. The control of the for loop is identical. We rewind to the top of the list. We check for the validity of the current object in the list. We control the loop with a call to the next function. And for the current object, which is of type movie, we call the display function. The output from the doubly linked list is then in, first out order, and then last in, first out order. So the SPL fixed array requires that we define the size of the array when it's created. So on line 82, we see that we're creating a new SPL fixed array of size 3 and assigning that object to the movie array variable. Then on line 83 to 85, we insert 3 new movie objects at the respective indices in the movie array. On line 86, we've reached the capacity of the array, 3 elements. So we need to resize the array, and we do so on line 86 by calling the setSize function of the SPL fixed array and adjusting its size to 4 so that on line 87 we can insert the 4th object of type movie. Then on line 89 we iterate over the movie array and call the display function on each of the objects. So let's see how that ran. and it runs as expected. So within the PHP community, there is an ongoing discussion about the relative performance benefits of the SPL fixed array versus the native array. We recommend an internet search to read about the discussion of the performance benefits.